So, Assalamualaikum once again, class. So, we will continue our discussion on bearing stress, okay? This time, in this video, sa video na ito, which is the second video, we will be having our examples with regards sa bearing stress, okay? So, bearing stress, second video to. First things first, yung gusto kong i-emphasize sa kapag solve ng problem is make sure that your solution is in detail. Detalyado yung solution ninyo para hindi kayo malito when having your solution, okay? When during your analysis is di ka na kubuligan. Okay? First, what I usually do is first I am starting with the given. Okay? So first, refer to your notes, class. First is basahin niyo yung problem dyan. In figure 1, assume that a 20 mm diameter rivet. So see, first given is yung diameter ng rivet. Okay? Given. First is yung diameter ng rivet. And it is 20 mm. Okay? And ito yung rivet natin. No? It's 20 mm. Second, assume that a 20 mm diameter rivet joins the plates that are 10 mm wide. So yung thickness ng plates daw, hindi thickness, it's the width and thickness. Width ng plate is 110 mm. Refer to the figure, ito yung 110 mm. Yan daw yung ginan ko ni Kalapado plate no? Yung plate. Next, the allowable stresses are 120 MPa for bearing in the plate material and 60 MPa for shearing of rivet. So, yung value ng bearing stress natin is 120 MPa. Diyan ko na plate material na kagaganian ang bearing stress na 120 MPa. Tapos, sumasok rivetan no. Ayan, diyan rivet na sayaw, gia connection nila. Nakuso rivet na yan yung shearing stress na 60 MPa. So that's 60 MPa. So what is being asked are, first, we have to find the minimum thickness. Okay? Tunakon, ipinakamay to iyan thickness para magaganyan para ko na plate na kagaganyan bearing stress sa 120 MPa. Second, natunakon pinaka-mana. What is the maximum? Okay? Mean to say na, what is the largest average tensile stress in the plates? Tunakon, tunakon yung pinaka-mala value o normal stress sa isa plate. Okay? So, yun, na-execute na natin yung given at saka kung ano yung hinahanap. Next is, let's do the solution, okay? On how to solve this problem. First things first. Sometimes in strength of materials, yung sinasabi ko kanina, it is a matter of you identifying kung ano yung binigay na illustration or ano yung binigay na diagram for you to analyze properly kung ano yung hinahanap. Okay? At saka para ma-analyze mo kung ano yung behavior ng isang system or yung isang bagay o isang object. Okay? For example, this one. Okay? Sa problem na ito, problem number 1, imagine this plate, top view niya is ito. Okay? Yung libro na ito, this one, is the top view. Pero kapag side view natin is magiging ganito yung information. Ito siya. Okay? So basically, yung 20 mm is yung diameter ng rivet na nandito. Meaning to say, the connection of these two plates. Yung rivet is yung connection ng two plates na yan para di yan ma-plug. Second, yung 110 mm is giya ka na din sayaw. It's 110 mm. Second is yung 120 MPa tapos yung 60 MPa for bearing and shearing stress respectively. So yung hinahanap is ano daw yung pinakamaliit na value ng ito, pinakamaliit kung ang thickness yan para magaganon dia bearing stress sa 120 MPa. Second is tunakon yung pinakamala value ang normal stress. kapag namital na, ito ang pinaka-value value normal stress. Key plate or key magia plates. Okay? Nagit so kuha saya sa analysis saya. First, we have to use sa pag-solve ng problems dapat magamit natin lahat ng given na yan. Okay? Usually, yan ay pugusan tanong para sa ma-analyze ng problem. First, for sa letter A, base. First, i-analyze natin yung stress na nararamdaman ng rivet. So, ano yung nararamdaman ng rivet na stress? Considering gesso force. So, ito na yung mo rivet na stress. It's shearing stress, right? Bakit? Shearing stress if mo rivet. Basically, again, let's use these books. Diba, imagine lang usually bro. Diba, add na force saya, si scissor force. Diba, gusto pag-lumit na force, tensile force, si saya so rivet. Diba, rivet, lagyan na to circle saya. Dia circle saya, dia rivet. So, meaning to say, since dia to circle, this kanyan. So, it is parallel to the force. Since parallel to the force na shearing stress, diba? Yung sabi natin kanina, sa shearing stress is the application of load parallel to the cross-section area. This time, yung parallel dito sa force is itong rivet. At saka bakit rivet yung ginanalis natin, hindi yung plate? Basically, di ba? Iginagamit kaya, ayaw pagagdam sa stress, ayaw pagagdam sa force na gia-rivet. Di ba? Ginagamit ka? So, gia-rivet saya, gia-connection nila. Nagnagamit kaya na gia-ip ka stress, gia-rivet. Okay? Yan ke pasangan pa ba? Magiging maawid na ginagamit ka, ay ke pasangan na gia-rivet. Sabi to, so, ano yung formula ng shearing stress natin is tau equals to P over A. Ginamit natin P kasi yung ginamit dito is P. Right? So, yung A natin, area natin is ano? Anong area natin? Again, yung area natin is this one, yung rivet. And yung rivet is 20 mm diameter, right? So, since DS kanyan here, di ba, DS of a force, nakatay sa rivet. So, since they are the one who are parallel, so yung gagamitin natin ng area is yung rivet, which is diameter or which is circular. So, force over pi over 4d squared. Nagkits ito? So, ito, dia force na parallel na dia rivet. Area rivet. So, force is equal to tau times pi over 4d squared. Okay? Nag-get so kaya cross multiply. Kaya pag cross multiply na yaw. May value yung tau natin, our shearing stress natin, which is 60 MPa. Tapos times pi over 4. Diameter natin is 20. This one. This one is 20. Oh, here. Yan na. 20 mm diameter. Again, sa strength of materials or sa ating engineering, igira ang nakilagay sa value na unit yan metric or whatsoever in there for English. Tapos, it is being followed by this symbol or this omega. Meaning to sina diameter diameter pag minsan. So, next thing, so diameter natin is 20 squared. 20 squared. So, pakilabas yung calculator, pakicalculate. Wala yung solving, calculate din kayo times 0.25 of pi times 20 squared. Or, alisin na lang natin yung pi para simplify yung answer natin dito. So, 6,000 pi. Okay? Sabi to, dahil pag pidaso payo, dahil pidaso question pag sa payo para dito pwede po yung solution. Next, bakit hinanap ko muna? I mean, in one first, pinubanong sa value of force. Di ba, the value of force pinubanong sa value of force. Kasi, nasa problem number 1, or first problem, letter A, naya saya pakaisin so thickness. Para makuha tanong so value of thickness na kailangan tanong so value of force. So, since thickness yung hinahanap, ang kailangan natin is bearing of plate material. So, meaning to sinabi, so bearing stress at curve mo plate, okay? So, bearing stress is equal to force over area. So, again, if you were to imagine about this problem, so bearing stress of material. So, giyo, di ba? Sisaya so livid, sisaya so force. Ay, tanok mo ba yung ginagaya thickness? Giya kakapalin na? Giya kapalin. Ito na ako na kakapalin na yan, para magagawin yan, so, bearing stress. Giya. So, sisaya so bearing stress, pumibit ka saya. So, meaning to say na, di ba bearing stress is the application of load that is parallel to, perpendicular to the cross-sectional area. Tapos, with two separating bodies. This time, yes, of course, so, natry para perpendicular ron. Di ba? Di perpendicular ron. But then, yung ina-analyze natin is two separating bodies. So, naba, di pusat ano. Ay, tanong pusat na giya, saya. Okay? Giya, saya. Nagets? Di ka stress. Giya, so perpendicular ron. So, meaning to say, ayan na po na, ano yung area? P over thickness, since yung hinahanap, times yung what? Diameter ng rivet. Okay? Yung diameter. So, it's the diameter. Tapos, let's solve for this one. Cross multiply natin itong dito. Diba? Force over P times diameter. So, B, T, D equals to force. May value yung bearing stress natin, yung thickness yung hinahanap, tapos yung diameter ng rivet, tapos yung force. Okay? So, which is itong dito, yung value dito. So, bearing stress natin is 120 MPa times yung thickness, which is the unknown, minimum thickness. Tapos, yung diameter ng rivet is 20 equals to 6,000 pi Newton. So, yung value ng minimum thickness is, pag-solve, calculator. So, 6,000 pi over 120 times 20. So, yung value is 7.85 mm. Okay? Ito yung answer sa first na hinahanap natin. So, meaning to say, giyan ko nga 7.85 diya, nagyan ko na yung pinakamay to a value o thickness yan. So, kakapalit. Para magaganin diya 120. So, meaning to say, mas malaki sa 7.85 is mas kagaganin sa 120. Okay? So, ibig sabihin din dito is, dapat hindi bababa sa 7.85 yung kapal nito para this kailan mag-fail. Nagigits ito? Again, aya buat tamanan, aya pinakamay to a value. O giya kakapalian na. Giya. So, tignis saya po. Aya pinakamay to a value niya na 7.85. Once, mbaba na sa 7.85, meaning to say na pag-fail giya, plate tan, okay? Pag-fails ka niyan. So, again, concept kasi sa strength of materials is the measurement. I mean, pagilay tano so sorong or pagilay tano if pagkagagaso so material pusang tano. So, yun. This is the minimum thickness. Next, letter B. Okay, this is letter B. So, ano daw yung maximum tensile stress in the plate? Largest average tensile stress in the plate. So, this is normal stress, right? Again, normal stress that is perpendicular to the cross-sectional area. Ano yung formula ng 1? Diba? Sigma is equal to force over area. Tapos, what is this? That one. So, this time, ano yung force natin? Same force natin is dito, 6,000 Newton. 6,000 pi Newton over, di ba yo, na perpendicular area ron? What do you think is the perpendicular area? Huh? So, this time, Yung ln natin is yung thickness times the width, right? Thickness aguso width. Yes kanina? Yung this is thickness, I guess so, width ng plate. This will be the plate to. So meaning to say na that is thickness natin times, since hinahanap natin is yung maximum, pinakamalakas stress, so meaning to say ang kailangan natin is itong dito na part. Dia saya apart. Dia. Si saya sa maximum stress. Ino to. Ilayan naman ng, di ba, thickness times yung width ng plate, tapos i-minus natin yung diameter. Nagito to? Ilayan naman ng 110 minus 20. 7. Okay. So, gusto ayan na equals to force over thickness, yung nasolve natin, times yung width ng plate minus diameter ng rivet. Okay? So, yung force natin, which is 6,000 pi over yung thickness, 7.85 times yung width ng plate yung nandun, 110 mm minus diameter, which is 20 mm. So, paki-calculate, this is the maximum tensile stress. Remember, yung normal stress is divided into two. Tensile stress at saka yung compressive stress. Okay? So, 6,000 pi over 7.85 times 110 minus 20. And the value is 26.68. 26.68 MPa. Gets? So, yung maximum value tanong para sa normal stress. So, again, tanong yung minus sa 20. As you can see, for example, upang gilin tanong, di ba kaya i-analyze tanong, kasi nasisan so maximum stress. Siso maximum. Kasi napigaan nyo man na, if saya tanong nag-analyze, saya part i-analyze tanong. If dyan tayo nag-analyze, dito sa iba, ako niya na yan, minus 20 niya na yan, divider nyo man na, 6,000 pi over 7.85 times 110. It's 21.68. Di ba mayas na ito sa 26.68? Another thing, siseso ko so i-analyze kasi sa part na ito is dyan mismo yung pinaka-delikado na part. Okay? Saya sa pinaka-delikado na part, saya sa part, amyak kalala stress kagdan yan. Okay? Kasi nang add na ko na saya. Add na tunabin niya, add na naburon o din na space on. Naging to, again, ang i-analyze natin na part, meaning to say, ang pinaka-critical na part sa plate na ito is this one. Okay? Ito yung pinaka-critical na part sa plate na ito dahil nandito yung placement or nandito yung location ng rivets natin. So that's why we have to do the 110 minus 20 because that is where the maximum stress is and can be located. Okay? So let's continue to second problem. Again, if you have any more questions or clarifications, just comment down below with your full name. So here we are with problem number 2. Okay? Again, execute muna natin yung given at saka kung ano yung hinahanap. Okay? Para mapadali yung analysis natin all throughout this discussion or all throughout the problem. So, the lap joint shown in figure, itong figure na ito, is fastened. Meaning to say, pinagdikit by using 4 na 3/4 inch diameter rivets. So, given, yung diameter ng rivets ay 3/4 inch. So, itong 4 na rivets na ito is 3/4 inch yung diameter. Tapos, ano daw yung maximum load P that can be applied if the shearing stress in the rivets is limited to 14 KSI. So, yung shearing stress daw is limited to 14 KSI. And the bearing stress in the plate is limited to 18 KSI. Okay? So, yung hinahanap is safe load P. Okay? Safe load P. So, kapag yung question sa problem, kapag yung question is ano yung safe load, ito, anong safe load na P? Kapag yan yung question, we need to say, kailangan natin isolve yung P sa shear at saka P sa bearing stress. Kasi, titingnan natin kung ano yung maliit na value sa dalawa, tapos, kung masolve natin yung P sa dalawa, we need to say, yung P sa shear stress at saka P sa bearing stress, kapag i-compare natin, tapos makita natin yung maliit, we choose the smaller value. Okay? Pipiliin natin yung smaller value. So, solution. Okay? Check natin sa diagram natin. As you can see, we have these 4 rivets. Kanina, sa first problem is, same lang yung analysis. Actually, same lang yung analysis. But this time, 4 yung rivets. Okay? For example, this one. Again, imagine this one, top view. Okay, top view niya, no? Having 4 rivets, di ba? Top view, ayan. Tapos, kung sa side view, ganito. Yung 4 na rivets na yan is magmumukhang 3 sa side view. Gets ba yung figure? Kasi lagyan na may sa pangasaya. Okay? So again, this time 4 rivets. Kanina sa problem number 1 is isa lang yung rivet natin. Okay? So, itong plate natin is may 7/8 inch na thickness. So, now yung hinahanap is ano daw yung safe value na load natin. So first, consider natin yung sa rivet kung ano yung force na kung ano yung application ng force dito sa rivets, okay? Based on first is yung sa based sa shearing on of rivets. So meaning to say, shear stress yung titingnan natin dito. Formula again ng shear stress is force over area, right? So again, yung area dito is parallel to the force. Parallel to the force. So, hinahanap again is force is equal to tau over area. Pero what do you think is the area? Okay? What do you think is the area, guys? So, yung sabi ko nina, iba ito yung force. Di ba ito siya? Ito yung force, di ba? Ito yung force. So, ano yung parallel sa force? So, meaning to sa ito, yung parallel sa force ay yung diameter ng rivets. Ito sila. Ito. Upama, nagiran ang nakared biyanan. Nagiran upama, so, igira ayatan ng pag-analyze na shearing stress, na ayaran pagkagdam na saya. Kasi naparallel sa force, di ba? Kumbaga, nakapag shearing stress, ayaw pagkagdam sa shear stress na saya. Especially, it is parallel to the applied force. So, meaning to say, na area niya na tau is tau times, again, ilan yung diameter? 4, di ba? So, 4 na pi over 4 d squared. Nagito to? So, 4 na pi over 4 d squared. Ano yung value ng tau natin? Or shear stress natin? 14 KSI. Tapos, 4 daw na pi over 4 times the diameter. Diameter is, ayun, 3/4 inch squared. Okay? Pwede i-cancel lang ito. Pag-calculate, 14 times pi times 3 squared over 4 squared. So, yung value is 24.5 24.74 kips. Okay? So 24.74 kips. That is based on shearing of rivets. Next, ang i-analyze natin is yung 18 KSI. This one is based on bearing of plates. Okay? Yung kanina, yung i-analyze natin kanina is yung, what is this? Yung based on shearing of rivets, meaning to say this one, the parallel to the force. But this time, yung i-analyze natin is yung based on bearing of plates. Meaning to say bearing is, di ba, dalawang materials? Yung plate at saka yung rivet. Okay? Yung plate at saka yung rivet. This one. Yes, saya. So, di ba, para perpendiculars ka yan? Meaning to say na nandito. Okay? This is our plate. Nandito yung rivet. So, ito yung force natin. CCS of force. So, what is perpendicular to that force is this one. Okay? Gay perpendicular sa iko, force. Nag-gets ito? Gay na ni perpendicular sa iko, force. So, if we are to analyze this one, formula ng bearing stress is same force over area. Pero sa bearing stress, again, it's the force is perpendicular to the cross-sectional area. Of course, P is equal to stress times area. Ang stress natin ay, or area natin ay ano? Of course, as you can see, di ba? Yung thickness, of course, ilan yung bolt na nandyan? 4. Meaning to say, there are 4 contact. May 4 na contact dito sa force, may 4 na contact yung plate sa bolt. Kasi 4 yung bolt natin, or 4 yung rivets natin. So, obviously, it's 4. So, 4 times ano yung area? Area natin is thickness times the diameter. Okay? Thickness times diameter. Nandito to? Yeah. So, kung sa thickness yan, yes yan. Di ba? If it would zoom out, ano? How should I do this? This one, no? This one. Yeah. Kung i-zoom out natin yan, this one, giyared saya, kung i-zoom out natin yan, ito yung magiging formation yan. Yan yung, that one, this is the thickness, and this is the diameter. Nakikita to? Diba? Tapos, ito yung load, ito yung force, this one, it's also force. So, meaning to say, thickness times the diameter, and ito yung force, that is perpendicular to the area. Yes, saya? Sa bearing stress, ayak po lang din na yes, sayaw. Nakikita to? Sa bearing stress, yung nakaka-feel ng stress is ito, itong dito. Gets? Pero sa shearing stress, yung nakaka-feel ng stress or supplagdam po stress, supplagdam po shear stress na yes, saya. Okay? This one is parallel to the force, and this one is perpendicular to the force. And of course, bearing stress must be perpendicular to the cross-sectional area. So that's why we will be using the thickness times diameter. Okay? So let's substitute the value for each notation. So, yung bearing stress is 18 psi times 4. Yung value ng thickness is 7/8. Yung value ng diameter, which is 3/4 inch. Pwede i-cancel lang natin ito. So, as you can see, pag-calculate, so 18 times 7/8 times 3. So, the value is 47.25 kips. Okay? So, ano yung sabi ko kanina? Kapag ang hinahanap is safe load, all we need to do is to compare the derived answer or the final answers of those forces na nakuha natin. Based sa shear at saka based sa bearing stress. Again, yung pinakamaliit na value. Saan dyan yung pinakamaliit na value? Obviously, it's 24.74. So, the safe value would be safe load, that is P safe, is equal to 24.74 kips. Okay? So ito, yan yung safe load na na-analyze natin. So, bakit nga ba yung maliit yung kailangan natin? Kung kukunin natin yung safe load, bakit yung maliit? Obviously, pagyaran nyo man na, kapag yung load natin is 47.25. Imagine nyo, kung yan load din na 47.25, nag-satisfy ka na sa bearing stress na, satisfy, okay, kasi na same sila ng value. Pero, kapag yung i-calculate natin is shearing stress, satisfy ba? Hindi. Considering na ito yung force. Obviously, hindi. Meaning to say, once yung gamitin natin na load dito is 47.25. Again, take note, once yung gamitin natin na load dito is 47.25, sa bearing stress, okay siya. Okay? Pasok siya sa 47.25. Pero, kapag yung i-analyze natin is shearing stress, hindi siya pasok. Kasi as you can see, it's just 24.74. Meaning to say, lagpas yung value, meaning to say, lagpas yung 47.25 sa 24.74. Meaning to say, mag-fail yung shearing stress natin. Meaning to say, mag-fail yung rivets natin. May ito to? Again, kinuha natin na value is yung maliit para masatisfy both sa bearing stress at saka shearing stress. Meaning to say, safe siya sa bearing at saka shearing. Okay po ba yun? So, yan yung analysis kapag yung hinahanap sa problem is yung safe load. Always choose the smaller one para masatisfy lahat. Okay? Again, piliin yung pinakamaliit na value para masatisfy, for example, yung shear at saka yung bearing stress. So, that is all for the second problem. So, I believe I will let you explore kung paano i-solve yung problem number 3. Okay? So, try to solve and analyze problem number 3 kasi same lang yung analysis dito. But in problem number 3 is so problem number 3 is Clevis. Okay? But that is just the same with the questions dun sa number 1. So again, make sure to download the file that I have posted. Nandiyan lang sa what is this? Nandiyan lang sa link na i-provide ko. So this is the second video and then yung third video is following. Okay? So this is all for the problems sa bearing stress.